All right, here we are going to find two numbers whose difference is 100. So we'll start with x minus y is 100. And that which we are trying to minimize is the product. So we're going to say p is equal to x times y. So we know that it is going to be p that we're going to be taking the derivative of and setting equal to 0 to find its critical numbers, because that's where minimums and maximums occur. So I'm going to substitute. So I'm going to set x equal to 100 plus y. And I'm going to substitute that into here. So I get 100 plus y times y. And I'm going to multiply it out first before I take the derivative. So I get p prime is equal to 100 plus 2y. Setting the derivative equal to 0 finds critical numbers. So I get y is equal to negative 50. So I want to find the other number, so I put that back into here. So I get x is equal to 100 minus 50, so x is equal to 50. So these are the two numbers that occur when the product, this product formula equation has a critical number, and that's where the derivative equals 0. So this is a minimum. Find the dimensions of a rectangle with perimeter 100 meters. So that's what's called our constraint. So I have 2x plus 2y. Oops, eraser. 2x plus 2y. My dimensions of my rectangle, and I want the area as large as possible. So it's area that's equal to x times y, and I'm thinking that's what I'm going to take the derivative of and set it equal to 0 to find its critical numbers. So I'm going to substitute, or first I'm going to solve for y this time. 100 minus 2x divided by 2 is equal to y. Let's fix this before I put it into the other function. So separating around the subtraction in the numerator. So I get y is equal to 50 minus x. Substituting that in, I get x times 50 minus x. So multiplying it, 50x minus x squared. Now I'm going to take the derivative. So I get 50 minus 2x. Set it equal to 0 to find its critical numbers. So I get x is equal to 25. So I want to find out what the y value is. So I put that back into here. So I have y is equal to 50 minus 25, so y is equal to 25. So it turns out to be a square. All right, so finding this volume of this box wants to be 100 cubic centimeters. So to draw the box, it's got a square base, x and a height of h. It's not a cube necessarily. So I want to find the volume, which is going to be x squared h, and that's 100. So that's our constraint, and I want the amount of material used, that is surface area. So I want to minimize the amount of surface area. So the surface area will be, it has an open top, so it just has the area of the bottom, which is x squared, plus 4 sides of area xh each. So I'm going to take this and I'm going to solve it for h, because that's the easiest letter to solve for, and there's just one of them. So I'm just going to simplify this to s. So I get x squared plus 4x, and I'm going to put this in for h, and I'm going to simplify this before I go take a derivative. So I get 400x over x squared, so that turns into that turns into x squared plus 400 and x to the negative 1. I'm getting it ready like that so that I can take the derivative in the next step. So the derivative will be 2x minus 400 x to the negative 2, and I'm setting that equal to 0. So I'm going to move this to the other side. So I get 400 x to the negative 2, or 2x equals 400 over x squared. I'm going to cross multiply, so I get x cubed over, or equaling 200, and then I get x is equal to the cube root of 200. So to find what the height is going to be, I'm going to take this and put it back into here. So I get h is equal to, and I'm taking the 200, which is to the 1/3 power, and I'm squaring it, so that's to the 2/3.